We've been looking at exponential functions, things like y equals 2 to the x. And if you remember, we knew that the points that it went through were always 0, 1, and 1a. So in this case, for example, y equals 2 to the 0 power is 1. So the point is 0, 1. Or y equals 2 to the first power, which gives us 2. So the point would be 1, 2. Other functions that we've looked at, we've been able to reverse those functions and perhaps solve for x. Well, at this point, we don't know how to do that yet unless it's a very simple function. So what we're looking at today is how to undo an exponential function. And to do that, we use something called the log. For example, if we have something like 2x to the 8th, if we want to be able to solve for x, we've looked in previous lessons that we have to match the bases. So I can rewrite this as 2 to the x equals 2 to the third power, since I know that 2 to the third is equivalent to 8. Since my bases are equal, my exponents are equal, and I get x equals 3. However, if I have something like 2 to the x equals 9, I have no way to equate those bases. This is where we introduce what's called the log function. I can take the log of both sides of this equation, and then as we'll see in future lectures, the rules of logs tell us that I can then bring this x out front, giving me x log of 2 equals log of 9. And then to solve for x, I'm going to divide both sides by log 2, which gives me x is equal to log 9 over log 2. This is what we would call our exact answer. But if we want that as a decimal, we can use the calculator to find it. If we move over to our Desmos calculator, you can see here that if I go to function, I can determine the log of 9, close my parentheses, divided by the log of 2, close my parentheses, and that allows me to round this to 3.1699. So my rounded answer would be x is equal to 3.1699. And if I plug that in, that means that 2 to the 3.1699 power should be approximately 9. So let's check that. If I go back to my calculator and I do 2 to the 3.1699, I do indeed get 8.9998, which is very close to 9. We can therefore define this log function when we have some function f of x is equal to a to x. The log function is the inverse of the exponential function. And you can think of that as if x equals a to the y, then the log, we say base a of x equals y.